Hello everyone, good morning. I am Jaduk Mashana presenting one of my PhD research work named a novel customer service prediction model for the telecommunication industry using data transformation method and feature selection. Supervised by Dr. Muhammad Sakur Rahman, co-supervised by Professor Dr. M. Soel Rahman. Outlines we will start motivation and will finish with the conclusion. After the conclusion, we will present our future research plan. Now, motivation. Every business is related to the customer. Customers are the more valuable part of any business. Sometimes customers can switch services or even service providers. Such customers are called churn customer. Customers can affect the company reputation, public view, and of course, potentially large revenue source. In general, industry follows two main strategies to generate more revenues. One is increase the retention period of customers, and second one is acquiring new customers. It is believed that the most profitable strategy is the first one. The application, as I said, every business is related to the customers. So, a telecom industry, shopping, software service hosting, every business is related to the customers, and there is a probability of customers from there. Our research is focused on telecommunication industry. In telecommunication industry, customers' historical data are generally stored in the customer relationship management system. This data can be used to analyze the customer's behavior. Customer sum prediction model predict the probability of customers. If a company can identify the customers who are likely to churn, they can take necessary action to reduce their dissatisfaction and increase their retention period. Customer sum prediction problem is a binary classification problem, namely churn and non-churn. Now, due to review, many machine learning algorithm has been used to tackle the churn prediction problem, like recently knife base, random forest, fit for network, etc. etc. In this slide, this slide shows few studies where the researcher used few data stream method like the reference for uses uh, log transformation and rank transformation. Reference 12 uses discretization transformation and weight of evidence transformation. Reference 5 is a log ranked box cuts data score. Reference 5 and 7 uses feature selection method. So what is the research gap? US table clearly shows the research gap. They actually most of the research conducted one or two data sets. Only three of them use data span method, and they use only two or four data span method. The impact of data transformation method combined with the intersection of machine learning has not been investigated deeply. So there is a large room to explore the data transformation method in conjunction with intersection and representation learning models. Now, the objective of this research. In this research, we tried to close the research gap and propose a optimized machine learning models which can potentially outperform the state-of-art models. Now, our contribution, we developed several customer prediction models using data span method and machine learning classifiers. We used eight classifiers and six data span methods. The eight classifiers are uh, KNN, night base, logistic regression, random forest, decision tree, gradient boosting, feed power network, and recurrent neural network. And there are transfer methods are log, rank, Bosco, Z-score, discretization, and weight of evidence. We also use univariate feature technique to select the highest values. We use grid search method to tune the hyperparameters of the classifiers. Our experiment we conducted our experiment on four publicly available datasets, and our evaluation metrics are AUC, precision recall, and pressure. We also perform a statistical significant test, and finally, we provide a concrete decision on the best combination of data from method and prediction model. Now, multi-direction method. This is the this slide shows the data sets. This describes the data sets. Data set the number of support data set is 1 lakh, and data set 2 is 5,000. Data set 3 is more than 3,000, and 7 is more than 7. First, data set 1 is the balanced data set, and data set 2, 3, and 4 is the imbalanced data set. And now the closeout of our proposed cash flow prediction. Upgrading the data, we perform data pre-processing technique. We use data cleaning, missing value replacement, critical value encoding. We use level encoding. And then we use data transformation method. Here is the raw is the original data. There is no data transformation. After the transformation, we use new reference selection and we select the highest scored features. After that, we use gives us method for selecting the hyperparameter, best hyperparameter of the classifiers. After that, we use after training the model, we use technical generation for evaluating our models. We use C, piston, recall, and net measure as a evolution metric. Now the data transfer method, we use log data transfer method, which is ln of the data. If the data is zero, data value is zero, then it is zero, and if it is less than zero, then it is ln. For the rank data transfer method, we 10 percentile, 10 percentile rank. And for the box counts, we use the lambda value is 0.5. For zero score, we use conventional zero score. For the discretization, the bin value is 20 in this university study. And for the weight of evidence, the weight of evidence is the ln of proportion of event, that is churn, with the specific beam. This is the ln of proportion of x and y, proportion of event and non-event for a specific beam. Now, presentation, we use event presentation. For the data set on, we select 18 best preserve. And for the data set 2, 3, and 4, we use 15 highest scored feature. For the hyperparameter tuning, we use git search method. Git search method actually find the best parameter from a manually specified subset and provide the optimal combination of the hyperparameter that actually provides the best performance. This is the hyperparameter value we use for our model training. For the selecting the model parameters, we use git search method, and this picture shows how the git search method improves the prediction model, performance prediction model. When Sivalu changes, this affect the prediction model. When Sivalu is 5, it gives the highest value. So we use the C is equal to 5 for the logistic regression model. And another 3D view of the performance of FNN using Gitshub method. When the epoch size is 10 and batch size is 10, it achieves highest performance. So we use the epoch size 10 and batch size 10 for our model training. And the results, this heat map shows that this heat map shows the performance of our data transfer method combined with the classifiers on the data set on. In terms of AUC, we observe that whatever evidence is providing the best performance. We observe that for the auto evidence, random forest, linear regression, quick formula and gradient boosting provide us the better result. And we also observe the um, um, same result pattern for the in terms of measure for the precision and recall. We found that we found auto evidence is providing the best result. But recall, uh, uh, raw-based opinion provides the best result. However, the corresponding precision is very low, so it is not a big issue. So if we clearly want to mention the best performance in terms of web measure on the data set on, the raw-based AFNN provide us the 0.60 on score, and whatever evidence score is whatever evidence FNN score is 0.8. The whatever evidence-based FNN achieves the 30% improvement in terms of AUC, and in terms of web measure, it achieves 13.9% improvement. On the data set 2, we observe that whatever evidence is the winner, and second winner is the zero score. For each AUC, precision, recall, and net measure, this bar set is for classifier FNN. For the set 3, we also observe the same result pattern. Here, winner is the whatever evidence, and second winner is the zero score. For the dataset 4, we observe the whatever evidence is classified perform better, but second winner is the raw. So we can say that whatever evidence performance is achieves the most consistent performance across the dataset. Now we want to test the estimated measurement test. We use fit-proven non-parametric statistical test which doesn't assume any particular distribution of the data. And this test is carried on the similar level alpha is 0.05. Here the null hypothesis is there is no difference among the performance of the performance prediction model. This is the rank of the Friedman test. Here, whatever evidence rank position is on, and the score second one is zero score, and third is raw. This is the performance difference heat map. This is the performance difference heat map among the three methods in terms of p-value. When the p-value is less than 0.05, we assume that we consider it as a evidence of significance. So when we observe the heat map, we saw that see that the weight of evidence and row has a significance difference for log every except the zero score for every transformation. The weight of evidence shows a significant evidence of significance. This is the difference. This is the different performance difference. So weight of evidence perform significantly different than the others, and how they are different after the post-hoc home test, post-hoc test. We perform the home post test, and then we saw that weight of evidence versus log rank, and when for the when the significant 0.05, that is a significant difference among the weight of evidence and other DT methods, except that is a story if we consider the significant difference 0.05. and then the null hypothesis is rejected, but for the zero score, the one for single 0.5, this is not, this is not, there is no significant difference here. But for the single 0.1, this is there is a significant difference among the weighted evidence and zero score. Now we compare our studies with other studies. We compare our study with other studies. I've had the data set as the common and the measurement metrics as the common. For our study, we have evidence-based FNM achieves the UC 0.802 and net measure 0.8 and the other study runs 5 achieves 0.54. And for the reference on it achieves 0.63 and our model achieves highest model achieves 0.8. So our proposal model achieves 26.2% improvement in terms of AUC and in terms of measure it achieves 70% improvement. Now, question is why the transformation method improves the prediction performance. In this slide, we show first three attributes of the data and also done. This is the Q2 plot of the attributes where we saw that for the raw value, original value, the data is very skew and is not now distributed when we apply the data. The data that is improve is data value improves the data quality, and for the zero score it slightly improved. And for the second attribute, also whatever they also improve the data quality, and zero score also improves slightly. For data set 2, we saw that zero score and whatever evidence both are improving the data quality. So this data quality, and that's why they as they are improving data quality, the transformation method actually improving the prediction model's performance. For the discussion, we use 6 different data methods and 8 different classifiers on 4 different publicly available data sets. We compare we show the comparative indexes and statistical tests. Based on the statistical test, you can see that whether within this statistical arts statistical art classifiers have a great impact on improving the customer prediction model performance in telecom industry. Whether within this navigation, random forest, neural network, and guidance boosting classifiers show the remarkable improvement. Whether within the transformation method actually improves the data quality and it become more normal distributed data. Data become more normal distributed data. Prior work actually studied limited set of data transformation method and conducted only 1 or 2 data set. On the other hand, we explored many data methods and several data set. And we demonstrated the supremacy of whatever across the wall, across the several data sets. In few cases, whatever evidence failed to outperform the raw-based models, but the degree of outperformance is relatively very small. For example, in terms of egg measure, whatever evidence-based gradient boosting is worse than raw-based gradient boosting by only 4.2% in the data set 4. So data size is small, so we emphasize that this is due to the small and medium data set. For the data set on, the good evidence performance is consistent or constant and across the world classifiers, and this is because large data set and data vision decreases. The over evidence with the different model achieve 30% improvement in terms of AUC and 30.9% improvement in terms of tape measure. So notable performance improvement were found for all the data sets, especially for linear regression and FNN. We recommend what evidence in education and fit for a legal network to construct a successful customer prediction model. The conclusion, most of the cases, weighted evidence and judges could data smooth the improve data quality and improve the prediction performance. And the performance are significantly better. To support our experiment, we perform the non-biological statistical test and post-hoc analysis. We compare our proposed model with the two state-of-art techniques. To test the robustness, we perform our experiment on both balance and influence analysis. Now, in the future research direction, the proposed method can be tested on the other given data sets, and to extend our approach and the end of the claim, this approach can be implemented. This approach can be used for other data sets from other business sectors. Now, our future research plan, as evidence shows remarkable progress for sun prediction. Whatever can be used in a research domain where privacy is the main concern. For example, privacy preserving customer sun prediction. You all know that that is the main field of any machine learning model. Um, However, data may contain sensitive individual information such as medical record, financial information, and these data are probably sensitive both for legal and ethical context. So training a model using the sensitive data has become a new privacy concern when someone uses third-party cloud computing. Third-party cloud computing data monitoring use this law creates privacy threats. Privacy can be also compromised due to the dishonesty and curious service provider. Data can also be compromised unintentionally due to data diversity and future during the competition time. Training model of SAPAR, privacy attack when which leads a leak. Training model of SAPAR privacy attack and leaks the sensitive information on the training data. So we like to close the framework for privacy being across information model in the cloud environment. And in this purpose, we have to use for this purpose we have to use we would like to propose a framework for privacy preserving customer segregation model in the cloud environment. We want to use genetic behavioral network and modified intelligence for our targeted privacy preserving customer segregation framework. So, as the references, thank you.